Okay? Leave your quiz blank. Leave your quizzes blank. You guys can watch, and especially because you guys have been away, wait a day and then see if you can reproduce this from memory. Yeah? Oh, now you're testing me. Just this once, fine. I have to introduce you all to my favorite student. Oh, I like this student. What's her name, Matt? Read the name of the student. Anne who? Anne Serkey. She gets everything right. It's amazing. Some of you haven't figured it out, but that's okay. So on your test, there's a delay, and oh, I get it now. It's either that one or the other one of my favorite students is good old Ima. Ima Chekhov, right? Anyways, here we go. That's for an assignment that I don't mark. Oh, you got to get up pretty early to stay with me. Cam just figured it out. Okay, you with me? Right? On your test, which isn't that far away, that's a fib actually, I got a fair bit more stuff to throw at you. I will at least once ask you to draw a board diagram. I hate board diagrams, but they are informative for the structure of an atom. Probably if you don't already, you probably want a pink periodic table in front of you. Yep.
On your tests, are they like multiple choice or
Both multiple choice and written. I hate multiple choice, but the provincial is all multiple choice, so I'll practice it that way. The only thing I like about multiple choice is if you make a sloppy mistake, you still get 0. I can't find your mistake. On the written, I can try and track it down. It's going to be about a 50-50, 60-40 mix. So it says, draw board diagrams of an atom and an ion. Did you say ion? Of magnesium. So I'm going to do this to divide my page in half, and I'm going to zoom in like crazy so you guys can see at the back of the room. So magnesium, I found it on my periodic table. I noticed it's in row 3. That means there's going to be 3 shells. There's the nucleus. For magnesium, I have 12 protons. How many neutrons? 24, take away 12. 12 neutrons. What row is magnesium in? Row 3. So what does that mean? It means that there is at least going to be the innermost, the 2 electron shell filled. Then there is going to be 1, 2, 3, 4, 5 pair, 6 pair, 7 pair, 8 pair filled. Then how many in row 3? Now I count over. Magnesium is 1, 2 over. So there's going to be 1. Oh, heck, I'll put 1 there. 2. Just not a pair. That is a Bohr model for magnesium. I'm going to tell you how I give out part marks in a second. However, if you have, by the way, if you couldn't fit the protons and the neutrons in the nucleus, if you wrote them over here instead, that's perfectly fine. I have to zoom in really big in order to do it, but I can't do it when I'm writing really small very easily. What did I make this worth? 6, I think, yeah? So 3 marks for each. I would probably do something like this. 1 mark for the nucleus, probably a half mark if you wrote the number of protons correctly, and a half mark if you got the number of neutrons correct, which means hopefully it's tough for you to get 0 on these. Then I would, I'll take questions at the end, hang on. Then I would probably go 1 mark for the inner shells. And since there's 2 inner shells, probably a half mark for the 2 and a half mark for the 8. And then I would give you 1 mark for the outer shell. What's the fancy schmancy word for the outer shell? Begins with the letter V. Okay, 1 mark for the valence shell. Yep. Do I not get that mark if I put them together? You use too many pronouns and not enough nouns in that sentence. I don't know what you mean. Put what as a pair? Oh, okay. If you paired the outer ones up, I'm going to take a half off because they only start pairing after you have the first 4 filled in, and I want to make you a little grumpy and angry at yourself about that, so you won't do that on the test. So we're going to take a painful half mark off. You're going to circle it, make a little note to yourself, put a chip on your shoulder so that when you get to the test, you'll be saying, hey, Dueck, you're not getting me on that one, right? That's I honestly, if I can get you guys coming to tests kind of angry, like, I'm not falling for that. That's how I want students to write tests. That's the much better way. Yes?
In the nucleus, if you wrote 12 neutrons and then 12
Yeah, it's fine. Yeah. Okay. Ion. Did I say ion? Starts out the same, because in an ion, we're not mucking around with the nucleus. We will be mucking around with the nucleus when we look at radiation, because radioactivity, actually what that is you got crazy stuff going on in the nucleus, protons and neutrons decaying. So unlike in Science 9, when we said to you the number of protons never changes, in Science 10, the number of protons or the number of neutrons eventually will start to change. But for now, 12, 12. What row is magnesium at? Third row. Now that third row, magnesium, metal or non-metal? So as a metal, it wants to lose its valence shell. So there is going to be 2. There is going to be 1, 2, 3, 4, Courtney pair, Courtney pair, Courtney pair, Courtney. By the way, that's why I always count it that way on purpose. It's to reinforce with myself. I go north, east, south, west, pair, 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 right? It's an ion. So it's gotten rid of its valence shell. Those 2 outer electrons aren't there. Now, if I just stop here, though, the marker might think that I made a mistake, that I forgot to add the shell. To prove that it's an ion, did I say ion? I put square brackets and its valence charge, like that. Okay? How will I mark this? Almost the same. 1 mark for the nucleus, 1 mark for the inner shells, half each. And then I would say no outer shell. I would go half mark for the square bracket, and I would go half mark for the 2+, but I would be mean. If you drew an outer shell of 2 electrons, I'm taking a whole mark off, because that's an ion. I want you to realize ions don't have partially filled valence shells. That's crucial. Is that okay? Lewis diagrams. Atom and ion of oxygen. I think I'd probably, again, go something like that. For both of them, the start is the same. That's not a nucleus, that's the letter O. All I care about for a Lewis diagram is the valence shell. So although oxygen is row 2, I don't care about showing that innermost circle. I'm just going to count across 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Oxygen is going to have, ready, Court? 1, 2, 3, 4, pair, pair, 6. That's the atom. Yeah? I'll take questions in a second. Hang on. Let me get through everything, and then I'll take questions. And then usually what I do is at the very, very end, I'll say, come lawyer with me, because it's much easier if I can look at your paper and give you a... ion. Oxygen, metal or non-metal? So does it fill up its shell, valence shell, or does it lose its valence shell? It gains, so it's going to have 1, 2, 3, 4, pair, pair. It's going to pick up 2 extras, and then to show that it's an ion, I put the ion square brackets and ion charge. What did I say this was worth? Really, I said 6? Okay, I should have made it 4. Oh well. 6, I guess 1 mark for the symbol. I guess 1 mark for the outer shell, and I would guess 1 mark for pairing them properly. I don't know. I should have made that one worth a couple less. On the right-hand side, it's going to be fairly similar, but a lot easier. I would go 1 mark for the symbol, the O. 1 mark for the valence shell. Half for the square bracket, and a half for the -2. The 2 negative. What if I wrote -2? I probably wouldn't take marks off, but traditionally it's written the magnitude and then whether it's positive or negative. Taylor, you had a question, or did I answer it? Yeah. I'm going to give you a temporary 0, and I'm going to say be mad at yourself for not reading the instructions, and then I'll say if you want to, you can reprint the quiz later on tonight or tomorrow and redo the quiz and get your score and get the marks back. And that'll sting, but that way you'll, again, I'm all about, honestly, if you make a mistake, I kind of want to grind my thumb on it like a bruise so it stands up, because I want you to be PO'd at yourself, and I'm not doing that again. That's the whole point of making a mistake. A mistake should be a little bit painful so that you know you're not going to do it again. I hope that's the goal. It's a little weird, I know. Draw a Lewis diagram of Li2O. First thing, before I even start, ionic or covalent? How do I know it's ionic? Just by glancing at it. Okay, metal. So ionic is going to look different from covalent. Ionic, did I say ionic? It's going to be square brackets. Which one is there the fewest of, lithium or oxygen? Oxygen's going to go in the middle. Lithium here, lithium here. Oxygen normally has 1, 2, 3, 4, 5, 6. Lithium, don't write this down, this is wrong, normally has 1, but each lithium wants to lose their outer shell electron. I'll change colors just to show you that those extra electrons, one of each, came from lithium. Each of these is now an ion. Did I say ion? There is a Lewis diagram of lithium oxide. If you got that, you get 6 marks. How many different atoms did I draw? 3? Is it going to, you know what? I was going to say 2 marks per atom, but the lithiums are identical. I'm probably going to say 3 marks for each of these. I'd probably go something like this. 1 mark for the symbol, 1 mark for the bracket, 1 mark for the ion charge. 1 mark for the full valence shell, half mark for the bracket, half mark for the ion charge, and 1 mark for the symbol. Is that 6? 1, 2, 3, 4, 5, 6. If you're missing a lithium, you lose an entire mark. Who was there? Okay, thank you. Something like that. And by the way, the fancy word for this, I think I've used it before, we call this an ionic lattice. What we're saying is in lithium oxide, you have oxygen molecules surrounded by 2 lithium molecules, and that just repeats over and over and over and over and over and over. These are not very strong bonds. Covalent bonds, much stronger. I think I told you guys that's why almost all explosives are covalent bonds, because in breaking the covalent bonds of explosive, lots of energy is released. Those are very, 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 very strong bonds. Covalent. Lewis diagram. Sulfur dichloride is how we would say that, which is what we learned last day. We said for covalent, you put a prefix, mono, di, tri, tetra, in front of the second one for sure, in front of the first one if it's not 1, but this is a mono, so I don't bother saying it. Which one is there the fewest of? Sulfur, it's going to go in the middle. How many chlorides? 2 of them? Now, how many extra electrons does chloride need to fill its shell? Look at your periodic table. How many? 1. You see how you can figure that out? So how many bonds covalent is each chloride going to have? So I'm going to go like this. 1 covalent, 1 covalent. And remember, the lines stood for not 1 electron, but for how many? 2. How many? 2. How many? 2. This is important, because how many does chlorine want in its outer shell? Grand total. 8. How many have I drawn with that horizontal line? How many more do I need? 1, 2, 3, 4, 5, 6. I kind of reason my way to drawing the covalent Lewis diagrams. I kind of work my way backwards. I do the covalent bond first, and then I ask how many more do I need? 1, 2, 3, 4, 5, 6. Sulfur, how many does it want in its outer shell? Also 8. How many does it have right now? Careful. 4. 4. How many more does it need? Pair there, pair there. Square brackets, no, because this is not ionic. So if you did that, you get, what did I make this one worth? 6 marks. Otherwise, I'd probably go something like this. I would give, change colors, Mr. Dueck. I would give you 1 mark for the symbols for all 3. I'd probably give you 1 for that, 1 for that. That's up to 3 marks so far. Then I would give you 1 mark for the outer valence shell of having 6 dots, 1 mark for the outer valence shell having 4 dots and 2 solid lines, 1 mark for the outer valence shell having 6 dots and 1 line. I think that's a total of 6. The symbols are 1. So if you wrote CL, S, and CL, you get 1 out of 6 at least, even if you had trouble. And what I'm really trying to teach you guys is don't ever leave a written blank if you can avoid it. Write something down. You might get some part marks. Can you give yourself a score, please, out of, count them, is it out of 24? I did my math right? Give yourself a score out of 24, please. And if you need to lawyer with me, now is the time. We talked about covalent compounds, and from now on, Sage, whenever you see either a chemical formula or a name written out, before you do anything else, the first thing you're going to ask yourself is this covalent or ionic? Always. And that's a habit you want to develop. Then, how can you tell it's ionic? Except there is one non-metal ionic compound. It's on the back of your pink sheet in the polyatomic ions. Can you look at the back of your pink sheet? What's the one positive polyatomic ion? You're going to get used, that NH4 is going to pop up a lot. That behaves like a metal, and it will have a non-metal after it. That's the only time you'll have non-metal, not covalent. And you'll just have to recognize, keep an eye out for NH4, that polyatomic ion. However, if it's aside from that exception, if it's a non-metal, we said they're covalent. So 2 classes ago, we reviewed the IDE rule. We reviewed the IDE. We said first the metal stays the same. You add an IDE to the end of the second, and that's how you name it. We said if they give you the name, you uncrisscross to figure out the formula, or you crisscross to figure out the formula. Ooh, we said it was tougher for multivalent charges, unfortunately. Covalent. Both more difficult and easier. More difficult in that sometimes both names change. We said we use a prefix of, how do I know it's covalent? Non-metal. We use the prefix of mono, di, tri, tetra, penta, hexa, hepta, which is on your pink sheet on the back, right? So we practiced a few. We said NO5 would be nitrogen pentoxide. We said SO4 would be sulfur tetroxide. We said tetraphosphorus decasulfide. Tetra means 4 phosphoruses, so P4. Deca means 10, sulfide, S10. Problem. You're going to have to also pay attention, Rachel, to sulfide, sulfate, and sulfite, because those are polyatomic on the back. You have to pay attention to chloride, chlorate, and chlorite. And again, I didn't name them. What you have to get in the habit of doing now is reading really carefully. I gave you a couple of sheets, and I'm going to start out by saying, I think the first one I gave you is more practice with ionic compounds. Were there any of these that you were going, holy smokes, Mr. Dueck, I have no idea how the heck to get this? Is that a hand up or a stretch?
Hand up. You know the projector's like not doing anything, right? You trying to do that, or?
That was silly of me. I had it frozen. Thank you, Alex. As I'm yakking away, I thought I was so proud showing you guys things. Questions from this sheet here, from more. Now, these were ionic. Today, all I'm doing is pressing pause, and I'm going to be giving you a gazillion of these, unfortunately. Any of these that you tried that you want me to go over? Okay? Yep.
I just call one your mistake.
Where?
What you
No, it doesn't count.
does count.
Nah, stop clicking with the pen. Thank you. I know, but not when I'm talking. Okay? So I'm going to assume that if, probably not on Wednesday, but probably after we come back, if I give you another take-home quiz, that I can give you either a name in English, and you can come up with the ionic formula, even multivalent ones with Roman numerals, or I can give you the formula, and you can come up with a name. Okay? Careful. Bad physics, Cam. Then I also think I gave you this one here called chemical names and formulas. This one had a mixture of some ionic and some covalent, and that's why I was asking you ionic or covalent. Were there any from here that you were going, I can't figure out how the heck they got that answer? Now is your chance to ask. And I think I said I was going to give you some time to work on it in class today, and you will. We're not doing anything new today. And then also remember from a couple lessons ago, there was these textbook assignments as well. So this was from when we reviewed naming ionic multivalent and ionic regular, going from name to formula, formula to name. Mr. Dueck, why are you flogging this so much? Rachel, the next topic is what's called balancing equations. And balancing a chemical equation, you can't do it unless you can actually come up with the individual chemical formulas first. If you can do that, then in all honesty, balancing a chemical equation, it's equation solving from Math 8 on steroids. Tough, but doable. But if you don't master this, you can't get the other stuff all that well. Doesn't mean freak out if you're having trouble. It means if you're having trouble, you want to catch me and come in for help. So, I said I'm pressing pause. I'm going to throw a bunch of extra stuff at you, and I'm going to shut up. So hang on a second.